Hello class, and thank you for watching. In topic 1.11, equivalent representations of polynomial and rational expressions, we're going to focus on dividing and figuring out the quotient of two polynomial functions using long division. Now, dividing polynomials using this algebraic process, similar to numerical long division, involves the quotient and remainder. If the polynomial f is divided by the polynomial g, then f can be rewritten as the product of my quotient q times my divisor g plus this remainder polynomial r, where, like I said again, q is the quotient, r is the remainder, and the degree of r is going to be less than the degree of g. Now, the result of polynomial division is helpful in finding the equation of slant isotopes for the graph of rational functions. Now, recall from the previous lesson, the way we determine again the slope isotope, or no, I'm sorry, let me rephrase. In order for a rational function to have a slant isotope, is that the degree of the numerator has to be higher than the degree of the denominator, like we see right here, but no more than 1 unit higher. So if our degree up here is 2, the only way that this rational function has a slant isotope is the degree right here is 1. And we're going to figure out what the equation to the slant isotope is by using, again, long division. Now, long division works, like I said, the same thing as long division with numerical values. We start by getting this on the inside of our long division box and this on the outside. So again, out and in. So we're going to start by writing 2x plus 1 using our long division box like in elementary school and grade school. We're going to write 6x squared plus x plus 5. Now, the procedure here to divide this is the same as with numerical values. The difference is, instead of trying to figure out how many times can this go into this entire thing here, we only focus on the degree, or I'm sorry, the leading term. So I only focus on the first term of my dividend, which is the 6x to the second power, and the first term of my divisor, which is just the 2x. Okay, and that's all I really want to divide. How many times can 2x go into 6x squared? So we just simply use normal division. I'm going to do the work over here on the side, as you see, and I'm going to divide this. Well, 6 divided by 2, that's a total of 3. And to divide the exponent, the variables, the x's, I simply subtract the exponents. And since it's a difference of 1, this is going to be x to the first power. So I'm going to write that above here, above the linear term of x to the first. So for this example here, dividing 6x squared by 3x, I'm going to end up with this. Having divided that, the next step in our long division procedure is now to multiply this quotient with our divisor. So we're going to distribute and multiply all of this with this. So we're going to end up getting 3 times 2, which is 6x to the second power, since x times x is x to the second. And now we're going to multiply 3x again with 1. So that's a total of 3x to the first power. And we're done. Our next step, and our third and final step, for at least for this procedure right here, is to now subtract these quantities. I want to get this value here and subtract it by there, which is easiest just to simply get the signs. Change the signs to these values, change them to the opposite sides, and then follow my addition rules of integers. Since these signs are different, I would subtract. This is a negative, this is a positive. I would subtract these numbers, giving me a total of 0. Since these numbers are different signs of positive and negative, the rules in combining different signs is to subtract those numbers. So 1 minus 3, or 3 minus 1 is 2x, and I keep the sign of the larger value, so negative 2x. And then I bring down the 5, since I haven't used that one. And now that I'm done there, I follow the exact same 3 steps and do the same procedure again, but this time with the negative 2x squared plus 5. So I begin by dividing and focusing on the leading term of each, the dividend and the divisor. So I'm going to get negative 2x and divided by positive 2x. Well, negative 2 divided by 2 is negative 1. And the x's, because they're both of the same degree, they reduce each other out. So all I'm left with is negative 1. So having now this, I'm now going to only focus on this new quotient, not the entire thing, just this new term right here, and multiply this new term with my entire divisor. So negative 2x is multiplied with negative 1, giving us negative 2x. Negative 1 is multiplied with positive 1, which is negative 1. And now I subtract, which is easiest is just to simply switch the sign to these quantities and then follow my addition rules of integers. Since the signs are different, I would subtract these two quantities, and 2 minus 2 is equal to 0. So that gets eliminated. And here, the addition rule, since the signs are the same, is to add these numbers and keep the same sign. So there's going to be positive 6. And there, we are done. So there we have successfully used long division to get the quotient of this. Now, this part right here, this quotient, is the actual equation to the slant isotope. So in the sense here, what is the equation of the slant isotope? Well, our equation will be 3x minus 1. This is going to be our slant isotope to this rational function to f of x. What does the r represent? Well, the r is simply a remainder. The remainder really doesn't affect what the equation is going to look like. That's just, again, the overall remainder of this thing. And this thing has a remainder of 6. But what we're focusing on and looking for today is going to be the slant isotope. So the equation looks like this. And if I draw a sketch of this, this has a y-intercept at negative 1. And it has a rise of 3 over 1. So it's going to go upwards, where the distance from one point to another point is a ratio of 3 over 1. And we cross the y-axis at negative 1. Because this is the slant isotope, this rational function of f of x, the end behaviors to the left and to the right are going to be pointing to negative infinity on the left side, since this is pointing downwards, and positive infinity to the right side. So whether it's from above or below, this, again, slant isotope, is going to end up these end behaviors to be unbounded, since we don't have a horizontal isotope to bound these things. So we're going to describe the end behaviors using limitation. It will look like this. So the end behavior as on the left side of our function is to negative infinity, since the left end is pointing downwards. And the right end behavior of this rational function is positive infinity, since the right end is pointing up. So this is what we're focusing on today, identifying what the actual equation to the isotope is, what the end behaviors and what the end behaviors are to this rational function using, again, limit notation. Now, in previous lessons, we determined just the equation that was going to be parallel to the slant isotope, which we can determine by simply just dividing this number by that number. And if I divide 6 divided by 2, I see that I end up with 3x. So I know that the equation y equals 3x would be, again, the line that will be parallel to the actual slant isotope. Today, we're actually going to focus and actually find what the actual equation is, which is simply, again, identifying what the y-intercept is. So y equals 3x is going to have the exact same slope, but now we're looking again for what the vertical translation is to determine, again, when we're going to cross the y-axis to determine the actual equation itself. And in order to do this, we have to use, again, this technique of long division. So let's look at another example. Let's go to the back and let's try this example right here. Now this thing, again, has a degree of 3 on the top and a degree of 2 in the bottom. So we know that this is going to have a slant isotope. Now, in order to use long division, the first thing that we need, that I didn't mention on the other one, is that our degrees have to, again, go in order from 3, 2, 1, and we need to have a constant, which in this case it's omitted, so that's going to be 0. So we're going to have x to the second power plus 7x plus 6, and on the inside it'll be x to the third plus 4x to the second minus 12x, and since there's no constant, that constant is going to be 0, because we do need a constant, in other words an x to the 0 power, which is our constant. So in this situation, since we're missing that value, we'll have 0 for that place there. Now to divide this, again we focus only on the leading terms. Now I can determine automatically what the equation that's going to be parallel to the actual slant isotope is going to be. If I divide the leading coefficients of 1 over 1, that's equal to 1. So y equals to 1x. This equation right here is going to be parallel to the slant isotope. But to calculate what the actual equation to the slant isotope is, we're going to use long division to figure this out. So I begin by first dividing again the leading coefficient. So on the side, I'm going to focus on dividing these two quantities. So let's do that over here. So x to the third power divided by x to the second power. Well, 1 divided by 1 again is going to be 1. And here I just simply have to subtract the exponents. So 3 minus 2 is 1, so 1x to the first power. And we're going to write that one right here above the x to the first power. So 1x to the first. And I'm not going to write the number 1 right here. It's understood again to be a 1. And the same thing right here. I really don't need to write the number 1 right there. It's understood to be a 1. Now what I'm going to do with this number is multiply this number again with the entire dividend. To my entire divisor, to what I'm dividing by. So 1x times x squared, that's 1x to the third power. Let me write this in black instead. 1x to the third power. This times now with this term, that's going to be a positive 7x to the second. And again, multiplying this with the 6, that's positive 6x. We're going to now subtract. So the easiest thing to do to subtract is to just simply change the signs to these terms and use my addition rule of integers to decide if I'm subtracting or adding. If the signs are the same, I add, but if the signs are different, like right here, I subtract. So 1 minus 1 is equal to 0, so this gets eliminated. These are different signs, so I'm going to subtract these numbers. 7 minus 4 is 3, so it's going to be 3x to the second power. And since the 7 is bigger and negative, that means that this is going to be negative. Now since these two signs are the same, I'm going to add these two numbers. So that's a total of 18x. And since they're both negative, there's going to be negative 18. I'm going to bring down the 0. And then I just do this entire procedure over again. This time focusing only now on negative 3x squared with 1x squared. So negative 3x to the second power divided by 1x to the second power. That equals to negative 3. And to divide the x's, I simply subtract the exponent. So that's x to the 0 power. And x to the 0 power is equal to 1. And multiplying negative 3 with 1 is negative 3. So I'm going to put minus 3 right there. Now I do the exact same thing and multiply this with my entire divisor. And we're going to end up with negative 3x to the second. Negative 21x and negative 18. So you see I multiplied this by negative 3 and I got that. I multiplied positive 7 with negative 3 and that's how I ended up with that number there. And I multiplied 6 with this number right there and that's how I end up with that. Now to subtract these quantities, simply change the sign to everything. Every positive becomes a negative and every negative becomes a positive. And then I follow my integer rules of addition. Since the signs are the same, I subtract these numbers, which is going to give me a value of 0. These signs are also different, so I'm going to subtract these two numbers, which is 3x. And the same thing with these. 18 plus 0 is just 18. So this right here is my remainder. Now, the remainder doesn't help me again in terms of what is the equation of our slant isotope. The quotient, this right there, is the equation to our slant isotope, which is y is equal to 1x minus 3. So this, again, just like the previous example, is going to be a line that has a y-intercept, this time at -3, that is slanted upwards, where the distance from one point to another point is a ratio of 1/1, since 1/1 is equal to 1. So just like the last example, the left-hand behavior of this function is unbounded, decreasing to -infinity. And the right-hand behavior to this function is positive infinity, because the right end is going increasing, again, unbounded. So the y values are always decreasing on the left, and they are always increasing, going to positive infinity, on the right. So this is the end behavior to this rational function using limit notation. So let's look at another example. In our final example here, notice that our numerator is not multiplied out. It's in factored form. This factored form is not going to be helpful nor useful to figure out the slant isotope in order to do this long division. So I need to first multiply this out. So we need to multiply 2x with x plus 4 times x squared minus 1. I'm going to start by multiplying first the binomials. So using FOIL, I'm going to multiply this out. So we have 2x, x squared minus 1x plus 4x minus 4, x squared plus 3x minus 4, and then distributing this term all the way in here into the three terms there, we're going to end up with 2x to the third power plus 6x to the second power minus 8x. And since there is no constant, that will be plus 0, or x to the 0 power. So this is going to be, again, our numerator. So setting this up again for long division, I'll have our x squared minus 2x plus 1, our divisor on the outside, and our numerator on the inside. So like the previous examples, we'll start by focusing only on the leading terms of both the dividend and divisor, and that's what's going to be divided. So 2x to the third divided by 1x to the second, that's 2x. So that's going to go right here, and the reason again it goes right there because it lines up again perfectly with this one, 2x to x to the first, x to the first. Now let's multiply all of this with our divisor, and we're going to end up with 2x to the third, negative 4x to the second, and plus 2. We're going to change the signs to these values here, so this becomes negative, this becomes positive, and it's going to become negative, which then lets us to do this becomes 0. Since these signs are the same, they are going to add up to give us 10x to the second power. And the same thing with the next one. They're both going to give us, oh, I forgot to put the x right there. Also negative 10, but x to the first power. We're going to bring down the 0. And now do this all over again. This time with this term here and this one. So 10x to the second power divided by 1x to the second, that's just simply going to give us a total of 10. So plus 10. So we'll multiply 10 now to the divisor, That's going to give us a total of 10x to the second power minus 20x to the first, and then plus 10. Let's switch the sign. So this becomes negative, this one becomes positive, and this one's going to become negative. This becomes 0. On the next term, their signs are different, so I'm going to subtract those. That's going to be a difference of 10. And since 20 is bigger and positive, that means it's going to be positive 10x. And then, well, 0 minus 10, that's equal to negative 10. And again, this is my remainder. Now the equation of our slant isotope, that's y equals 2x plus 10. And again, since let me write this down first. This is d of x, not f of x. Let me give it the right name, d of x. So for this one right here, since this again has a positive slope, it's going to go upwards. Again, my x and y axis. The y-intercept is positive 10, and the slope is positive 2, which means that from one point to another point is going to have a ratio of 2 over 1. So this is again our slant isotope. This rational function is going to look again and behave on the left end by going again down like this slant isotope. And on the right end, whether it's from above or below, is going to be pointing upwards again from that position there. So like the previous two examples, with anything with a positive slant, the left end is going to be going towards negative infinity, and the right end will be going towards positive infinity. And let me just box it in, and there's our answer. We have the equation to our slant isotope. We have the end behaviors on the left and on the right. And we use long division again to calculate this equation, this isotope. Well, that's it. This is nice and short on how to use long division to determine the equation to our slant isotope. If you have any questions, please do not hesitate to send me a message on Parent Square through email. And like always, I appreciate you watching, and I hope you have a great day. Good day. Goodbye.